My name is Megan Zilla, and I did my project on action potential. Action potential occurs in an excitable cell. They only occur at the nodes of Ranvier when a stimulus occurs. The first phase of action potential is the resting phase. The blue dots represent the sodium ions, which are more outside the cell in the extracellular fluid, and the red dots represent potassium, which are more inside the cell, which is the intracellular fluid. The orange is the semipermeable membrane, which allows for the sodium and the potassium to go in and out of the cell. The blue gates are the sodium voltage gated ion channels, and the red gates are the potassium voltage gated ion channels. Notice that both are closed, which when they are closed are called inactivation gates, and this is because there is not yet any stimulus occurring in the resting phase. The second part of action potential is threshold. This is where the action potential begins and the sodium gates begin to open. After threshold occurs, depolarization begins. In this phase, the sodium gates open completely and the sodium rushes into the cell. This is called an influx. The potassium gates remain closed and the cell becomes more positive, which is called an overshoot. Once the cell reaches its maximum potential, it enters repolarization. This is when the cell becomes more negative. In this phase, the sodium gates close and the potassium gates open. The potassium then rushes out of the cell rapidly. This is called an efflux. In some cases, more potassium can leave the cell than normal, and when this happens, it is called hyperpolarization. The last part of action potential is the refractory period. At this point, both the sodium and the potassium gates close. Then the sodium-potassium pump activates using energy, otherwise referred to as ATP, to pump 3 sodium out of the cell and 2 potassium back into the cell, until the cell returns to its resting state, where it will remain until another stimulus occurs, and at that point, another action potential will occur.